Hello! In today's video, we're going to explore a really important topic in math: numbers. By the end of this lesson, you'll be able to answer some key questions. First, you'll be able to define what a rational number is. Second, you'll learn how to place any rational number on a number line. And third, we'll see how long division can turn a fraction into a repeating decimal. Numbers are everywhere in our daily lives. We use them to count things, measure distances, tell time, and even manage money. For example, you might say you are 12 years old, or your height is 1.5 meters, or it's 30 minutes past 2. You might even want to share a chocolate bar equally with your friends. All of these activities involve numbers. Just like animals are classified into different groups, like mammals or birds, numbers are also classified into different categories. Let's get started and meet some of these amazing number groups. Let's begin with one of the most important categories we'll be studying today: rational numbers. Our goal is to understand exactly what a rational number is. So, what are rational numbers? It might sound complicated, but the idea is actually quite simple. The word rational comes from the word ratio. A rational number is any number that can be written as a simple fraction, or a ratio, where there's a number on top and a number on the bottom. Let's look at that fraction, a over b. There are two very important rules here. The first rule is that the top number, which we call the numerator, must be an integer. Integers are the whole numbers and their negatives. So, numbers like 1, 5, 100, and also -2, -8, and -50 are all integers. And the second rule is even more important. The number on the bottom, the denominator b, can be any integer except for 0. It's impossible to divide by 0, so this rule is essential. Remember, you can't have a 0 on the bottom of a fraction. So, to recap, a rational number is a number you can write as a fraction a over b, where the top and bottom are whole numbers or their opposites, and the bottom number is not 0. Many of the numbers you already know are rational numbers. For example, all whole numbers like 1, 2, 3, and their opposites, the negative integers like -1, -2, -3, are rational. Even fractions like 1/2 are rational numbers. You have now successfully defined a rational number. It's simply a number that can be written as a fraction where the denominator is not 0. Now that we know what rational numbers are, let's explore how to show them on a number line. This is a great way to visualize where they live. The first step is to draw a straight line. This is our number line. In the middle, we place the number 0. Think of 0 as the starting point, or the origin. To the right of 0, we mark the positive numbers: 1, 2, 3, and so on. The further you go to the right, the bigger the number gets. To the left of 0, we mark the negative numbers: -1, -2, -3, and so on. The further you go to the left, the smaller the number gets. So, we have a perfectly balanced line with positive and negative numbers spreading out from the center, 0. But how do we place a fraction on this line? Let's take an example. Imagine we want to represent the number 1/4 or 1/4. Here, our numerator is 1 and our denominator is 4. The denominator tells us how many equal pieces to divide each unit interval into. Since the denominator is 4, we need to divide the space between 0 and 1 into 4 perfectly equal parts. Think of it like dividing a pizza into 4 slices. The numerator, 1, tells us to count one of those parts. So, starting from 0, we move to the first tick mark. That point right there is the location of 1/4. And that's it. By dividing the space based on the denominator and counting the parts based on the numerator, we can place any fraction on the number line. You have now seen how to locate a rational number on the number line. We've placed a simple fraction. Let's try a decimal number next. We'll learn how to represent a decimal number on the number line. Let's work with the number -2.4, or -2.4. Since it's a negative number, we know it's going to be to the left of 0 on the number line. The first thing we should do is convert this decimal into a mixed number. 2.4 means 2 4/10. As a mixed number, that's 2 4/10. We can simplify this fraction by dividing both the top and the bottom by 2. So, 4/10 becomes 2/5. Our number is -2 and 2/5. This tells us it's past -2, but not all the way to -3. So, we start at 0 and move left past -1 and then past -2. Now we are in the space between -2 and -3. The fraction part is 2/5. This means we need to take the space between -2 and -3 and divide it into 5 equal parts, just like we did with 1/4. The numerator is 2, so we count 2 of those parts to the left from -2. The second tick mark we land on is exactly where -2.4 is located. By converting the decimal to a mixed number, we can easily find its spot. Let's do one more example. We'll place a positive fraction that's greater than 1. How about 13/5? This is an improper fraction, which means the top number is bigger than the bottom. This tells us the number is greater than 1. To find its place, we convert it to a mixed number. How many times does 5 go into 13? It goes in 2 times, with 3 left over. So 13/5 is equal to 2 and 3/5. This means we go past 2 and into the space between 2 and 3. We divide that space into 5 equal parts because of the denominator 5. Then, we count 3 of those parts to the right because of the numerator 3. And there you have it. 13/5 is perfectly placed on the number line. We've now located both a decimal and an improper fraction on the number line. So, we've talked about fractions and decimals. Let's dig a little deeper into the world of decimals. Our goal is to understand different types of decimals. There are 2 main types of decimals we see with rational numbers. The first is a terminating decimal. This is a decimal that stops or terminates. It has a definite end. Think of it like reaching the finish line. Examples are 0.5, which is the same as 1/2, or 2.15, which is 2 and 15/100. They don't go on forever. Now, the second type is a little more interesting. It's called a repeating decimal. This is a decimal that never ends. Instead, a digit or a block of digits repeats over and over again in a regular pattern. You might have already seen an example. 1/3 is a repeating decimal. When you divide 1 by 3, you get 0.33333, and it goes on forever. The digit 3 is the one that repeats. To make writing these decimals easier, we have special notations. We can write the repeating decimal using a dot over the repeating digit, like 0.3 dot. Or, we can use a bar over the digit or block of digits that repeats, like 0.3 bar. Let's see another example with a block of digits repeating. Consider the decimal 0.474747. Here, the digits 4 and 7 repeat together, so we can write it with a dot over the first and last repeating digits, like 0.4.7. Or, we can put a bar over the entire repeating block, 0.47 bar. And here's an important fact. Every single terminating decimal and every single repeating decimal can be written as a fraction. This is the definition of a rational number. You've just learned about 2 major types of decimals. We've seen that 1/3 equals 0.3 repeating. But how do we go the other way? How do we take a repeating decimal and turn it back into a fraction? This is a great skill to learn. Let's learn how to convert a repeating decimal into its equivalent fraction. We'll follow a few simple steps. Let's take our example, 0.3 with a dot, which is 0.3333. The first step is to give it a name. Let's call it x. The next step is the clever part. Step 2 is to multiply both sides of our equation by a power of 10. How many? We multiply by 10 for every digit that repeats. Here, only the 3 repeats, which is 1 digit, so we multiply by 10. 10 times x is 10x, and 10 times 0.333 just moves the decimal point 1 place to the right, giving us 3.333. So we have a new equation. 10x equals 3.333. Now for step 3. We take our original equation, x equals 0.333, and subtract it from our new equation. This is the magic that makes the repeating part disappear. On the left side, 10x minus x is 9x. On the right side, the repeating point 333 minus the repeating point 333 is 0. We're left with 3 minus 0, which is just 3. So our new equation is 9x equals 3. The final step is to solve for x. To get x alone, we divide both sides by 9. So x equals 3/9. This fraction can be simplified by dividing the top and bottom by 3. Our answer is x equals 1/3. And there you have it. We've proved that 0.3 repeating is exactly equal to the fraction 1/3. You have now learned the process to convert a simple repeating decimal into a fraction. That was a great first example. Let's try one more that's a bit more complex. What if we have a repeating decimal where the repeating part doesn't start right after the decimal point? Let's look at the decimal 0.83 with the bar over the 3. This means it's 0.83333. The 3 repeats, but the 8 does not. We start with the same steps, but add one extra. First, we set our decimal equal to x, so x equals 0.8333. Second, we need to move the decimal point so it's right in front of the repeating part. Right now, it's before the 8. We need it to be before the 3. To do that, we multiply by 10. So, we multiply both sides by 10. That gives us a new equation. 10x equals 8.333. Let's call this equation 1. Now, we forget the first step and treat equation 1 as our starting point. From here, the process is the same as before, only the 3 is repeating, which is one digit. So we multiply by 10 again. Multiply both sides of equation 1 by 10. 10 times 10x is 100x, and 10 times 8.333 is 83.333. Let's call this equation 2. Now we have two equations, equation 1 and equation 2, both with the exact same repeating part, 0.333. Just like before, we subtract the first equation from the second. The repeating parts cancel out perfectly. We get 100x minus 10x, which is 90x, and 83 minus 8 is 75. Our equation is 90x equals 75. Now, to solve for x, we divide both sides by 90. X equals 75 over 90. Last, we simplify. 75 over 90 becomes 5 over 6 after dividing by 15. So, 0.8333, written as a fraction, is 5 over 6. Okay, we've gone from fraction to repeating decimal and back. Let's do one final practical example of how to convert a fraction to a repeating decimal using long division. This is a very important skill. We're going to convert the fraction 2/3 into a decimal using long division. Remember, the fraction bar means division, so we are dividing 2 by 3. We set it up like a regular division problem with 2 inside the division symbol and 3 outside. Our goal is to find the answer. First, how many times does 3 go into 2? 0 times. We write a 0 above the 2. Then, we subtract 3 times 0 from 2, which leaves us with 2. To keep going, we add a decimal point and a 0 to the 2, making it 2.0. We also add a decimal point to our answer. Now we bring down the 0. Now we ask, how many times does 3 go into 20? It goes in 6 times. We write a 6 in our answer. Then we multiply 6 by 3, which is 18, and subtract 18 from 20. We are left with 2. The result is 2. Now watch what happens when we repeat the process. We have a remainder of 2, we add another 0 and bring it down, making it 20 again. How many times does 3 go into 20? 6 times. Subtract 18, and we're left with 2. See the pattern? We will keep getting a remainder of 2. Because the remainder keeps repeating, the number in our answer will also keep repeating. The decimal part just goes on and on, 0.6666. This is our repeating decimal. So 2/3 is equal to 0.6, with a dot or bar. We have now converted a fraction to a repeating decimal, using long division. Just remember these steps. Set up long division, add a decimal point and zeros to the number inside. Keep dividing until you see a pattern repeat in your remainder. The digits that repeat in the answer will be your repeating decimal. Let's quickly recap what we've learned today. We've taken a big jump into the world of numbers. First, we learned what a rational number is. We found out that any number you can write as a simple fraction, a over b, where b is not 0, is a rational number. Second, we mastered how to place any rational number on a number line. We learned that 0 is the center, positive numbers go to the right, and negative numbers go to the left. We saw how to use the denominator to divide the space, and the numerator to count the parts. And finally, we connected the world of fractions to decimals. We discovered that dividing fractions can lead to terminating decimals that end, or to fascinating repeating decimals that have a pattern that goes on forever. And we saw how to use long division to find these patterns. By understanding these concepts, you are much better equipped for everyday tasks like measuring and sharing. Great job today, and keep an eye out because in our next video, we'll talk about numbers that are not rational, called irrational numbers.